Schrödinger's cat is probably one of the most famous and mind-bending thought experiments in quantum mechanics. But it may seem complicated, but let me break this down for you. So, let's begin with the basic concept of quantum mechanics. So essentially, quantum mechanics is the science of really small things that are so small that you can't even see them. And at that scale, the normal rules of physics don't really apply. One of the weirdest ideas in quantum mechanics is called superposition. It seems weird, but that's what happens with tiny particles. They can exist in more than one place at once until we look at them and then they choose, quote unquote, choose one place to be. So let's talk about the observer effect. Speaking of looking at things, let's look at another strange rule, the observer effect. This means that just by observing or measuring something, you could actually change how it behaves. And essentially, it seems as if you are seeing things differently, as if it's behaving in a different manner just because you're looking at it, because you're interacting with it. So essentially, let's talk about quantum entanglement. This happens when two particles become connected, and even if you move them far apart, like light years away from each other, they still affect each other instantly. So here's another weird trick in the quantum mechanical world. Quantum tunneling. So imagine you're trying to walk through this solid wall in my lab, and instead of hitting the wall, you phase through it, you walk right through it. In the quantum world, particles can actually do that. They can go through barriers that in our world should be impossible to pass. So quantum mechanics shows us that the tiny world of particles is nothing like the one we see around us. It's full of mystery and weird things that don't really follow the right rules that we are usually used to, and they're full of surprises. Alright, that being said, let's talk about Schrödinger's cat, because that was the original question. So, first, let's talk about what Schrödinger's cat is. So it is a thought experiment, which means it's an idea to help us understand quantum mechanics, not something that necessarily actually happens. So imagine you have a cat in a box. Inside the box, there's also a device that could either release poison gas or not, depending on whether an atom inside the box decays or not. If the atom decays, the gas is released and the cat dies. If it doesn't decay, the cat stays alive. So here's what gets really strange. In quantum mechanics, until we look inside the box, the cat is both dead and alive at the same time. That's because the atom inside the box can be in two possible states, decayed or not decayed, at the same time. And because the cat's life depends on its state, the cat is also in a mixed state. Essentially, the cat is dead and alive at the same time until you look at it. So this idea of being in two states at once is called superposition. So essentially, that's what I talked about earlier. So the same thing here with the observer effect. As soon as you look in the box, the cat chooses whether to be dead or alive. And that is the observer effect, the act of looking at something, forcing it to pick a state. Now essentially, what does all this mean? Schrödinger's cat isn't about actually putting a cat in the box. It's meant to show how weird quantum mechanics is. Things at the quantum level, like atoms and particles, don't choose a state until we measure or observe or interact with them. So the cat's life or death is uncertain until we look inside.